All right, let's get right into it. We're going to be talking about the incredible tech that's behind tools like ChatGPT. I'm talking about large language models, or LLMs. We're going to pull back the curtain and really figure out how these things actually, well, think.
You've seen it, right? It feels a little bit like magic. You type in a question and boom, this incredibly detailed, coherent answer just appears. But here's the thing, it's not magic. It's a really complex process, and that's the big mystery we're going to unravel right now.
So, let's start with the basics. What even is a large language model? At its heart, it's just a super advanced computer program. Its whole job, its entire reason for being, is to understand our language, the way we write, the way we talk, and then create new language that sounds like it came from a person.
I love this analogy because it just clicks. Picture an assistant that's read basically the entire internet, every book, every article on Wikipedia, everything. And it didn't just memorize it, it actually learned the patterns, the style, and all the little connections inside all of that text. Okay, so how does that learning actually work? Let's pop the hood for a second and take a look at the engine that makes these models go. It really comes down to a three-step process. First, you give it a digital library that is just mind-bogglingly huge. Then, because computers think in numbers, not words, it breaks all that text down into little numerical pieces called tokens. A token could be a whole word, or sometimes just a piece of a word. And that leads to the most important part. Step 3. The model has one single goal. Get insanely good at predicting what the very next token is going to be. Think of it like the world's most sophisticated game of finish this sentence.
But predictive text has been around for ages. So what's the secret sauce here? What makes these new models so different? The clue is right there in the name, large. We're talking about their massive, almost unbelievable scale.
And you can really see that turning point on this timeline. 2017 was the big one. The transformer architecture was an absolute game changer. It let models understand context over really long chunks of text in a way they never could before. That single innovation is what made this new level of scale possible, and it led directly to things like BERT and, of course, the explosion of ChatGPT in 2022 that put this power in everyone's hands. So when we say large, what does that actually mean? Well, it means a huge amount of data, a huge number of internal settings or parameters, and a very, very large price tag. Just to put it in perspective, estimates suggest that training just one of Google's big models costs something like $8 million. And that's just for the computer time. That's the price you pay for this kind of scale.
But here's the catch, and it's a big one. When these models learn from this ocean of human text, they don't just learn our good stuff. They don't just learn our creativity and our knowledge. They also learn our mistakes, our bad facts, and all of our biases. And that leads to some of the biggest problems with this tech. This creates this really interesting split personality. On one hand, LLMs can do things that are genuinely amazing. But on the other hand, they have these huge fundamental flaws that we have to talk about. So check this out. Once these models get big enough, they start showing what researchers call emergent abilities. These are skills they were never, ever programmed to have. A model that was only taught to predict the next word suddenly learns how to do basic math or unscramble words or even reason through a complex problem step by step. It's this wild, unexpected side effect of just being so massive. Now for the dark side. Remember, the model's goal is to generate a plausible sequence of words, not necessarily a truthful one. This means it can hallucinate. It will just make stuff up that sounds completely factual and confident, but is totally wrong. Look at this example. The AI confidently says the Sharks won the Stanley Cup in 2016. But they didn't. They lost to the Penguins. The AI just invented a fake reality because the words sounded right together. And then you have the problem of bias. The training data is packed with all of our human biases, and the models soak it all up and can even make it worse. This can lead to reinforcing stereotypes, like always associating nurses with women or engineers with men. Because so much of the data is in English, it can push a very Western-centric worldview. And yeah, it can even pick up and reflect the political leanings that are most common online. So, with all these incredible abilities and all these pretty serious flaws, where do we go from here? This technology is not some far-off sci-fi concept anymore. It's here, and it's forcing us to ask some really big, really tough questions about our future. And those questions get complicated fast. You've got huge legal fights over copyright. I mean, who owns the stuff they train on? Then there are real environmental concerns about the insane amount of electricity these things use. We're facing a future where it might be impossible to tell if something was written by a person or an AI. And we're seeing new security threats, like prompt injection, where people can trick the AI into ignoring its own safety rules.
There's no doubt about it.
We have built one of the most powerful tools for communication in the history of humanity. It has incredible potential for good and, yeah, some pretty significant risks. So the ultimate question really isn't about the tech anymore, it's about us. Are we wise enough to handle what we've created?